What's up, guys? This is Mr. Gaines here. I apologize in advance. This video is going to look a lot different than it has in the past due to the current nature of not being able to come to school. We're going to do the best that we can here to record you a good and accurate lesson here, starting off QF.2 notes. So we have just completed QF1 where we were working on solving quadratic functions, and now we are advancing on into QF2 where we are going to take a look at quadratic functions and their graphs. So as you guys may remember from Algebra 1, a quadratic function gives us a parabola when we take a look at its graph. So on the screen, I kind of have a sketched out version of a parabola here that we may take a look at. And this is basically what's going to represent a basic quadratic function. And we know the standard form for this quadratic equation. I went ahead and wrote it in function notation here, is f of x equal to ax squared plus bx plus c, where a, b, and c are all real numbers, and a does not equal 0. So what we may remember back again from Algebra 1 is we have some key features here. We can see that on the graph here, I have went ahead and I've put down some points and an axis or a vertical line here. The point over here on the left on the y-axis, we know that this is the y-intercept. And we know the points down here on the x-axis, these are known as the x-intercepts. This point we have down here at the bottom, hk, which I'm going to come back to in a little bit as to why it's labeled hk, but for right now it's just a point. We should know that this point is known as the vertex. It is essentially the origination point of the graph, the turning point of our parabola. It is, again, the vertex. And the one other piece that I have input into this graph is this vertical dashed line. This vertical dashed line is known as the axis of symmetry. Now, you may remember back from Algebra 1 or from earlier in this year when we talked about even functions having symmetry about the y-axis. This function has symmetry about this axis. Now, sometimes it is on the y-axis and it's an even function. Sometimes it's not on the y-axis, but the function will always be symmetric about the axis. So I don't have the greatest drawing here, but you kind of get the idea. It should be identical on both sides of this vertical dashed line. Now, some key things can be learned about each of these functions. And it relates back to what we did earlier in the year. When we take a look at finding some of these key features, the easiest one to find is going to be the y-intercept when it's in standard form. We know that the y-intercept is always on the y-axis, and the x value at that location is always going to be 0. So in order to find the y-intercept here, we can substitute in 0 for f of x and then solve. What you'll also notice that if I substitute in 0, it's going to essentially cancel out the ax squared because it's going to be a times 0 and then b times 0. And then all you'll be left with is c. So in standard form, c is always the y-intercept for the parabola. Now this is key that it has to be in standard form. We're going to see a different form of parabola where that is not the case. The other thing that we can find algebraically is the x-intercept. In order to find the x-intercept, we can use the skill that we worked on in the last unit, or the last target, which is solving quadratic equations. The x-intercept is the solutions of any quadratic equation, or setting that equation equal to 0 and then solving. So if we wanted to find these x-intercepts for any quadratic function, we need to set that function equal to 0 and then solve that function. So that takes us down to problem number 1. Problem number 1 says, if possible, find the x-intercepts and the y-intercepts of the following quadratic functions. So if we take a look at problem number 1a, we have the function f of x is equal to x squared minus 3x minus 4. This one should not be too complicated for us to find the y-intercept. So again, the y-intercept is setting x equal to 0. So if I substitute in a 0 for x squared, the x here with x squared, and I substituted in a 0 for 3x, what I would come up with is 0 squared minus 3 times 0 minus 4. which we could pretty quickly figure out that the y-intercept is going to be 4. So you could write it out as f of x equals 4, or write it out as y equals 4. So the y-intercept is just 4. And again, or sorry, negative 4. Again, you wouldn't have to do a lot of work here. If it's in standard form, the y-intercept is always going to be equal to c, the constant there at the end. Now, finding the x-intercept requires a little bit more work. So to find the x-intercept, we need to set the entire equation equal to 0. So what I could do here is take the equation x squared minus 3x minus 4 and let that equal 0. This gives us a quadratic equation that we can solve. So we want to use the skills that we learned in the previous target to try to solve this quadratic equation. So there's a number of different ways that we could do this here. The easiest in this case would probably be to factor. This is a pretty simple factorization here. So we would be looking to factor a quadratic trinomial down into 2 binomials. The first term in each would need to multiply together to give us x squared. So that's going to be x and x. The second term in each would need to multiply together to give us a negative 4. So we know one of these factors would be positive, one would be negative. Then we're looking for factors of 4 that through distribution would end up in a negative 3x. So we should have an x plus 1 and an x minus 4. So we can factor this equation, and then remembering the zero product property, we can set the factors equal to 0. So x plus 1 equals 0, and x minus 4 equals 0. And we can solve those individually by subtracting 1 in the first to get x equals negative 1, and by adding 4 in the second to get x equals 4. So our y-intercepts for this function would be negative 4. Our x-intercepts for this function would be negative 1 and negative 4. Now I can also check this graphically if I'd like to. So you guys have a graphing calculator that you can use. We're going to need to know how to do some of our algebra skills here, but you also have a graphing calculator that you can use. And what I'm going to do is I'm going to pull up a graphing website that you did use before in some previous classes, but because I don't have the calculator, it'll give us a good view of the function. So here on the screen, you should be able to see a graphing calculator version of Desmos. And I'm going to go ahead and just type in the equation that we graphed. And I can take a look at this graph, and I can see it does have x-intercepts of negative 1 and 4, and a y-intercept of negative 4, y equals negative 4. So you could list those as coordinate pairs if you wanted to, but you could also list those just as the individual point locations, the value for y for the y-intercept, and the value for x for the x-intercepts. So in order to find the y-intercept, we want to substitute in y, or 0 for x, substitute in 0 for x. To find the x-intercepts, we substitute in 0 for y, or essentially set the equation equal to 0, and then solve. Let's go ahead and take a look at another example. So in example B, we have the equation 9x squared plus 3x. That's the function. So I'm not even actually going to do a lot of work here for my y-intercept, because we know, again, we can substitute in 0, and we can solve or simplify that expression, and that would end up giving us 0. Or we can just pick the constant out of there. If we look at that equation, there is no constant after 3x, so that constant technically is 0, so the y-intercept is going to equal 0. The x-intercept, again, we do have a little bit more work to do. So in this case, we want to make sure that we set the equation equal to 0, or let h of x equal 0. So in this instance, we may realize that once I set the equation equal to 0, the quickest method here to solve would be to factor. So I can factor this using a GCF. I have a GCF of 3x, greatest common factor of 3x. So I can factor out that 3x, and I'd be left with 3x plus 1. And then I can set both of those factors equal to 0. So I would get 3x equals 0, and I would get 3x plus 1 equals 0. Then I can go ahead and solve these two equations individually. So divide by 3 in my first equation, and I would get that x equals 0. Then I could subtract 1 in my second equation to get 3x equals -1. And then divide by 3 to get that x equals -1/3. So here we can see some skills that we used in, again, previous lessons to find the y-intercept and the x-intercept. Let's go ahead and take a look at another example.